Okay, let me try this. This would be a follow-up to the coding on paper that I did this morning, except that I'm not sure that's ever going to upload from my phone. Just doing a little code here. I've trying to do some geometric stuff with color. This was all explained in the video this morning if it ever gets up. And I've started on the process of the final idea I had this morning of filtering a vector, finding the area between. I turn this on now because I'm dead tired and I'm about to import a module that's a real mess that I've been working on since 2006. I don't have near the linear algebra skills I had then, and so I have to go back. I borrow from this a lot, but I sometimes end up just copying out what I want. Sometimes make changes. It's always in the middle of some sort of rewrite. The nice thing about Git submodule is that you don't have to worry about changing things. When you go back to your project, it'll always find the last working version, so you can just keep making commits. You don't have to branch. It'll find the commit that it needs. So let's add that. And what does this tell me here? If you want to reuse this local Git directory instead of cloning from yeah, okay. That's because I did this once before earlier and erased it because I thought that I didn't need it. So now we're going to add it back in and see how that works out. So here's where did that go from? That went from that's right here. Okay, so what I need is going to be in here. We want the distance between a point and a line segment, which is pretty straightforward, but this will stop me from doing it again. You see this date here, 2016. Like I said, I think this goes back to 2006. There's 2013, 11. I don't always keep dates like that. You can see a lot of this lines and decorations are from when I was using Vim, and I didn't have all the editor features it would. There we go. That would put nice lines and decorations around your code, so I just would sort of add those things in with snippets. I'm going to try to just borrow this out of here because I've got this file that I'm putting together as a test of concept. And okay, that's not going to work. This pulls in too much code that's out of that module. So let me delete that. Was that point segment distance? You might have seen when I was loading that the difference between line distance and the segment distance is that you have boundaries and there's checks to see if something is exactly on a boundary or beyond it. But this should give me the next step in what I need. Let's segment here that's going to be 0. to my. So I'm trying to find out how much of my factor color I can fit into my target color. So I'm going to get as close as I can with the shared color channels, and then see if that's close enough. Right now I have, I just saw my epsilon is set to 0, so we're going to set that to, I don't know, let's try 10, just to get us a little into this and get some tests. Run that, and okay, yeah, NumPy is hell on Python type hints, and there's a module that came out to allow some type hinting for NumPy. You had arrays. The name of the object you pull out for NumPy was array, and they changed that to ND array, which is the same thing except it's got different rules. See here, you have array, float, 3, that means it's a float array. The size is 3. Now you can put in a whole shape, but for whatever reason it's also backwards. So you have to put in your shape and then your D type. And this was, I think I was playing with this when right after typing came out and got a little bit over enthusiastic with it. So there's probably going to be a lot of this to clean up, but maybe I can get through it quickly. Let me see if there are any other. Okay, that's it. Let's see what we got. Okay, yeah, see here I have a whole module just for types. Okay, let me see what it's going to take to clean this up. Hopefully not much. Maybe we can just quickly, if we can't, I might try to find a shortcut. And yeah, boy, there's going to be a bunch of them in here. I'm going to see that might even work. The technical way you're supposed to do it is, you know, when you have something of indeterminate size, you do something like that. And you can do more now. I mean, you could put this inside a tuple, and that would allow you to at least define the dimensions. I'm just going to try leaving this off totally and see if I can switch these to ND array, float, and yeah, okay, that's it. Let's see if that runs. Okay, no, I screwed up doing that. So, okay, oh goodness, okay, so another problem is I wrote this without, to work without NumPy, or I tweaked it to work without NumPy, and then now you have the, you know, array equals difficulty that you always have. So I'll mark this and, you know, import NumPy up top, and put a space so my completion works. Make sure I can remember. Yeah, okay. We'll just hack on this in a minute. Like I said, you don't have to worry too much about messing something up with a submodule, because you can either delete it. You know, this doesn't work, I might start over from scratch and try to clean it up, or you can just go about your business, make any changes you want, and it won't affect anything else where you're using this as a a submodule. So that's on my equals, and we'll try it again. No, okay. Okay, that's, yeah. I took a little shortcut here. I wasn't sure if it would work. I've got to have, I've got to have a vector here with the same shape. I'm going to do it a clean way. I want the same shape as the other two vectors. So I could just multiply 1 by 0, but we're going to try that just to do it the cleanest possible way. All right, let's see if this is sane. Target vector. Whoa. Target vector is okay. Yeah, I'm seeing the problem here. You know, these vectors have to sum to 1, and when I put that together, I wasn't thinking, and you know, I'm calling this a distribution of a color because it has some extra channels and because it sums to 1, but I did not account for let's just do this. No. Okay, so I'm going to normalize that down to 1, and at creation, this last value is a transparency. That's always going to be 0 because all of the channels are scaled to sub to 1. Let's try that again. And all right, so target vector is okay, and my factor vector is going to be very similar. It's got a little bit of extra color into it. This last channel here is going to be my my anti-blue channel, which is some way I put these colors together this morning. And let's see, a distance. That, okay, that's nice. That's nice. That's giving me something else. What is this giving me? What is this giving me? This is giving me, yeah, okay. This is giving me a segment distance. Okay. Yeah, so bonus. That's something else I don't have to, I won't have to figure out. But what I need, I have a segment that's passing in space, the same space where my, and the same plane that my target vector, target point that is on. And so I have the closest point on that segment, and I have the angle. But what I need is how much of that factor, you know, what portion of my segment that factor, or of my color, my target, that factor is meant to represent. So I need I need to treat this target vector as a vector, in case it might be a short vector, and my factor vector is longer, or maybe my factor vector is very short and my target vector is long, and so this doesn't end. It might be the closest point on the vector, but it does not end anywhere near the, Okay, that's a different question, isn't it? I need two distances. So the distance, if the target vector is very short, the closest point on it might be or the factor vector is very short, the closest point might be farther away than my, might be a good deal further away from my target than it is from a point on the vector towards my target. In other words, maybe the factor I'm mixing in is very small, and it's only going to take a portion of my target. So rather than approaching it with this very short vector, what it will do is it'll approach a portion of it. So what the distance that I really need, the distance I really need, so this is factor to target, and then I have another distance, target to factor, and this is going to be a little slower, but it'll save me the bother of figuring out the trig. I'm just going to do it the other way. So I'm going to look at my factor vector and find the closest point on my target to, okay, so the distance and factor point, right, is going to be this. The factor point is going to be the amount of my factor that fits best in. So now I want to move along my, find this factor point, and the closest, just to clean this up, the closest point on my target vector to the amount of factor that I've meant to use. As I said, I'm a little wiped out right now. Okay. So this will give me the exact amount that I need to remove. It'll give me a point on the factor vector that best approximates some portion of my target color, and it will also give me the point on the target color that will be approximated and therefore removed from my target. Once I've removed that target, okay, to do that I'm going to have to keep track of which channels we're keeping. This point here that just keeps whatever, that's not going to work. These are going to have to become a dictionary, or, okay, rather than that, I will zero out everything in the target vector. Rather than filtering, I will zero out everything that is, okay. Okay. Well, list comprehensions in Python are funny when they get to else. It sort of changes. I think the else is over here. It's goofy. It's goofy. Let's see. Let's test it. Let's see. So. And we're going to have for x in else 5, x in AAA if x is not equal to 2. Okay. Now I'm getting some red lines here. That's okay. That's obviously not right. Okay, that's wrong. What does it want from me? What am I missing? Okay, doesn't like the else. That's not where the else goes. I don't remember. I've only been using this language for 15 years, at least. X for X. Oh. I know it's not here, because that would be the logical place to put it, and I know it's not there. No. It's not there. Oh, I screwed this whole thing up. Let's try again. Okay, yeah. Okay. It doesn't. No, that's not right. Okay. Let's see. This is terrible. This is terrible. I'm going to have to look it up. You know, if I look it up, I won't remember it next time. The way is not to look it up. The way is not to look it up. The way is to remember it. Right? There's nothing shameful about looking something up, but it does not. That is not how you remember it. That's what I did last time. And this is it. That's it. That's it. That's it. That's it. Good. Beautiful. 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 Okay. Oh, hopefully that'll catch next time. So, if boy, how do you do that if you're zipping? I don't do it with a zip. Doesn't know what F. Oh, okay. Doesn't know what. No, it will. Okay. Zero. That's it. That's it. That's it. That's it. That's it. Okay. Just make sure that works. Yeah. Okay. So the shapes are different, but it looks like everything works. And then that makes the factor vector just equal to the factor. The input. That's fine. That's fine. We'll clean that up later. Let's see. Okay. Now the real distance that I need to worry about isn't this one. And I'm going to take this off just because it's not going to matter. I'm going to take this one off because it's not going to matter. It's just going to confuse me later. That's gone because I don't need that. That point is meaningless. The only meaningful distance is the second one, which means we can change that to distance. That's our error. That is the place where that is the distance between the reality and the approximation. And the distance is tiny, which it should be because I chose two input colors that were very, very close to each other. Now let's just refactor that. Get rid of that factor effect. Okay. Beautiful. And we'll just do this. Just to make everything cleaner. call that what it is. So you can't, that's another reason you can't just take the closest place between here, because one of them will be the origin. Okay. Beautiful. That's everything we need. Now, okay, if the distance is less than or equal to epsilon, we are going to subtract the target point from the target vector and add in some transparency to make the whole thing still equal to 1. So target is, let's just go ahead and transform this in place. I might decide to change that later, but let's, as an experiment. So target is less than target subtract target point. Yeah, that's good, because the transparency vector will always be 0, because the transparency vector in the factor will always be 0. So 1 is equal to, and I'm gonna, I might change the way these targets work. If I keep transparency at the end all the time, this will always work. So the target -1 is equal to 1 minus the sum of the target to that point. That way we know everything should. Let's check this out. Do the basic debugging here. There's the target. Now it has a little bit of transparency. Okay. A little bit of transparency. No. No, the target is very transparent. I pretty much just built the target. We're so close. Right? It's almost pure white, which is where we want to be. That's right. You can see that. You can see that here. How much of it is gone. Just see that as another way to look at it. There's nothing left. There's nothing left. That's how much pigment I would have to apply to go any farther with this. And let's just try something that's dramatically different. So we'll do a red for my, I'm going to call it pale yellow, and then let's say this is blue is my target. So there we go. Let's try that again, just to see how it works out. And we have what's left of the target. Yeah, that's, see all these channels here. This is, it's not red and not yellow, and you've allowed a little bit of that in there. That's not good. So let me see what that distance is. Basically, that's Of course, the distance between two vectors normalized this way is going to be very small. So the target point is negative. Negative. It's okay, so the target, the input target was blue, and this is negative green. Okay, I've got some work on that, but enough show for now. I will cut this off and continue working and hopefully make some good progress.